All right, so we just used our quotient rule in the last video where we could take one big radical and separate it into two smaller radicals if that helps us simplify. Well, we can also use that rule backwards. If we have two radicals that can't be really simplified, we can actually combine them into one big radical that might help us simplify a little bit better. Let me show you some examples. Number 3 asks us to divide and, if possible, simplify. So you notice on example number 3a, I have the square root of 700x over the square root of 7x. And if I'm looking at that denominator, 7 really can't be broken down any more than it already is, and if I only have one lonely x, there's no groups of 2 that I can take out, so I can't do anything with this denominator. I might be able to do a little bit with the numerator, but what happens if instead of doing them separately, we combine them into one? As long as they're both underneath the same type of radical, we can combine them. So instead of two separate radicals, I can really say that I have the square root of 700x over 7x. And then I can look on the inside. You notice that 7 goes into 700 100 times, and the x on the top, the x on the bottom, reduce to 1. So I really end up having just a 100 left underneath my radical. Well, what's the square root of 100? 10. That's pretty simplified, right? And so if putting them together helps us simplify, then it might be easier to do that first. Look at b. I notice on b that I have the cube root of 32 over the cube root of 2. And I know there's no cube root of 2. But what I also noticed is that they're both underneath a cube root. So instead of it being under two separate roots, how about we squish them together into one cube root? I still have the 5 on the outside, multiplied by the cube root of 32 over 2. Well, what is 32 divided by 2? Well, I ended up getting the cube root of 16. So I really have 5 times the cube root of 16. Let's see if we can break down 16 anymore. I know that 16 factors of 16 are 2 and 8. I know that 8 breaks down into 2 and 4, and I know that 4 breaks down into 2 and 2. If we can simplify, let's simplify. So let's look for groups of 3. I notice that I have a group of 3 here, and those 2's can come outside. This lonely 2 would have to stay inside that cube root. But remember, we still have a 5 that's outside also. So now I have a 5 and a 2 that are outside that I'm going to eventually multiply together. And then I have a lonely 2 underneath my cube root. So my final answer for simplifying this problem would be 10 times the cube root of 2. Let's do 2 more. Look at c. I have the square root of 75ab over 3 times the square root of 3. You notice that these are both underneath the same radical. Now there's a 3 on the bottom there, or can I say a 1 over 3? That's on the outside, a 1/3. And then I'm going to take those radicals and I'm going to combine them into 1 because they're underneath the same radical. So instead of the original problem, I'm going to say that I really have a 1/3 times 75ab over 3. That's going to help me a little bit because how many times does 3 go into 75? 25, right? And so now I have this problem that says 1/3 times the square root of 25ab. And look, isn't there a square root of 25? Is 5, right? So that 5 can come outside. The a is still lonely, the b is still lonely, so they stay inside. But now on the outside, I really have 5 times 1/3, or I can say 5/3. I can say that I have 5/3 times the square root of ab. All right, d has 5th roots. And again, as long as they're both underneath the same root, instead of doing them separate, I should be able to combine them. It might make it a little bit easier. Now, let's look to see what happens. Can I divide 2 into 64? Can I take my a's and put them together? And can I take my b's and put them together? You might have to remember your rules for exponents. Remember when we divide, we really subtract the exponents? So 64 divided by 2, I ended up getting 32. a to the 11th divided by a to the 1st. If I take an a from the top and an a from the bottom, I really just have a to the 10th left. And now be careful, if you brought this b to the negative 2 up, you'd have b to the positive 2, so you'd really have a total of 30 b's on the top, or b to the 30th. All right, now let's see if we can take this and still simplify. I'm looking for the 5th root of 32, a to the 10th, b to the 30th. Let's start by breaking down the 32. Factors of 32 are 2 and 16. Factors of 16 are 2 and 8. 8 breaks down into 2 and 4, and 4 breaks down into 2 and 2. And remember, looking for groups of 5. That's 1, 2, 3, 4, 5. Look at that. It looks like there is a fifth root of 32. It's 2 with nothing left over. All right, I have 10 A's. If I'm looking for groups of 5, what's 10 divided by 5? 2. I have 2 groups that I can bring out with no lonelies. I also have 30 B's. If I'm looking for groups of 5, what's 30 divided by 5? It looks like 6 even groups with no lonelies. So I have no lonelies underneath my radical. So that radical's gone now. I have a 2 outside, I have a to the second outside, and I have b to the sixth outside of my radical. No more radicals, no more lonely terms left over. And so that would be my simplified final answer. Make sure you know how to simplify using both your product rule and your quotient rule for radicals.